So hi everyone, in this video let us solve few questions from the exercise of your NCERT textbook. Okay, so the first question 7.1. Now this says a 100 ohm resistor is connected to a 220 volt 50 hertz AC supply. Okay, so you have a resistor of 100 ohm. Okay, and this is connected with the AC source. Now AC source is of 220 volt 50 hertz. 50 hertz. Okay. Now it is asked what is the RMS value of the current in the circuit. Okay. Now always remember that this AC source voltage, it is always the RMS voltage. Okay. So this is basically VRMS. Though it is not given in the question, but you have to understand this, that the source voltage is always the RMS voltage, VRMS. Okay. Now resistance is given, it is 100 ohm, and you are asked to find the RMS value of current. So IRMS, it is equal to VRMS divided by resistance. Okay, this is by Ohm's law. So what is the value of the VRMS? VRMS is 220 volt, and resistance of the resistor is 100 ohm, so it is 220 divided by 100 ohm. Okay, so 220 divided by 100, so that is equal to 2.2. So IRMS, it is equal to 2.2 ampere. It is current, so unit is ampere. Okay, so this is for part A. Okay, now in next part B, what is asked? What is the net power consumed over a full cycle? Okay, so power is product of voltage and current. Here in case of resistor, you don't have to worry about the phase because voltage and current, they are in same phase. So simply you have to take the product of voltage and current. Okay, voltage means this is VRMS and current is IRMS. Okay, so power is product of VRMS and IRMS. So VRMS is 220. So 220 multiplied by IRMS, we got it as 2.2. So 220 multiplied by 2.2. So this gives 484 watt as the power. Okay, so this is the answer to part B. Now in question number 7.2, again you have two parts. First part A, the peak voltage of an AC supply is 300 volt. Okay, what is the RMS voltage? Okay, now what is the relation between peak voltage and RMS voltage? VRMS voltage, it is equal to peak voltage divided by root 2. Okay, here peak voltage is given to be 300 volt, so 300 divided by root 2. Okay, so this, if you simplify, you will get this as 212.1 volt. Okay, 212.1 volt. So this is the value of the RMS voltage. Okay, next part B, the RMS value of current in a circuit is 10 ampere. Okay, what is the peak current? So IRMS, it is equal to peak current I naught divided by root 2. So that means I naught, it is equal to root 2 times IRMS. Okay, RMS current is 10 ampere, so this is 10 root 2. So if you simplify it, root 2 is 1.414, so 1.414 multiplied by 10, that is equal to 14.1 ampere. So this is the value of the peak current. Okay, so this is peak current. So this is answers to part A and part B. So next question 7.3, you have a 44 millihenry inductor connected to 220 volt 50 hertz AC supply. Determine the RMS value of current in the circuit. Okay, so you have an inductor. Okay, see, drawing the circuit is not necessary. Okay, this is just to make you understand a bit more. So this is inductor of inductance 44 millihenry. Symbol for inductance is L. So this is the inductor, and with a AC source of 220 volt 50 hertz, frequency is 50 hertz. Okay, now I told you this AC source voltage, it is always the RMS voltage. So here RMS voltage is given, and you are asked to find the RMS value of current. Okay, so again, using Ohm's law, you have I RMS, it is equal to V RMS divided by the term which opposes the current. So for inductor, the opposition term is XL. Okay, reactance of inductor, and this X subscript L, it is equal to omega L. Okay, omega is angular frequency, so that is twice pi times frequency into L. Okay, so if we substitute this value over here, we get the value of IRMS. So IRMS, it is equal to VRMS, it is 220 volt. So 220 divided by twice pi, frequency is 50 hertz. Okay, and this self inductance L, it is 44 millihenry. So it is 44 into 10 power minus 3. You have to convert this into Henry. Okay, so if you simplify this, you will get IRMS equal to, so this on simplification gives 15.92. So 15.92 ampere. Okay, so this is the required answer. So next is question number 7.4. So here you have a capacitor connected to AC source. Okay, so this is the capacitor connected to an AC source. Okay, capacitance is given, it is 60 microfarad. Okay, so this is the capacitance, and voltage is 110 volt, 60 hertz. Okay, so don't forget that this is the RMS voltage, and we have to find the RMS value of current. Okay, so again, using Ohm's law, we have I RMS, it is equal to V RMS divided by the term which opposes the current. Here you have capacitor, so you have capacitive reactance X subscript C, where XC, it is equal to 1 by omega C. Okay, so this is XC is equal to 1 by omega S twice by times frequency multiplied by C. Okay, so this is IRMS, it is equal to VRMS is 110 divided by 1 divided by twice pi, frequency is 60 hertz, and capacitance is 60 microfarad. So 60 into 10 power minus 6. Okay, so if you simplify this, so on simplifying this, we get the final answer as 2.49 ampere. Okay, so this is the value of the RMS current.